You are standing at 0, and you need to get to positive 15. However, there is a rule. You're only allowed to take equally sized jumps to get there. What do? There's a couple different ways to solve this problem. First, we could take 15 jumps, each 1 step long, or we could take one big jump that was 15 steps long. What other jump patterns exist? There's 2 more. We could take 5 jumps, each covering a distance of 3 steps, or we could take 3 jumps, each covering a distance of 5 steps. And what you've already probably figured out is that this is a way of drawing multiplication. What multiplication problems do these drawings turn into? In red, we took 15 jumps, each 1 step long. In green, we did 1 jump that covered 15 steps. In blue, we took 5 jumps, each of them 3 steps long. And in purple, 3 jumps, each 5 steps long. What if we reverse this? How would we do this with division? Let's say that you need to get to 20 from 0, but you're only allowed to take 4 equally sized jumps. How big is each jump? If we're only allowed to take 4 equally sized jumps, then each jump will have to cover 5 steps. 0 to 5, 5 to 10, 10 to 15, 15 to 20. What other jump patterns can we use to get from 0 to 20? Well, what if we're only allowed to take 2 equally sized jumps? Then each jump would be 10 steps. First from 0 to 10, then from 10 to 20. How about if we're only allowed to take 1 jump? Well, that big single jump is going to take us directly from 0 to 20. What do these look like as division problems? The first one, in red, we needed to get to 20 using 4 jumps. That means that each jump is 5 steps long. In green, we were allowed 2 jumps to cover the distance between 0 and 20, and that meant that each jump had to be 10 steps long. And finally, in blue, if we have to get to 20 and we can only take 1 jump to get there, that jump has to cover all 20 steps. The reason I'm bringing up these ideas of multiplication and division in terms of jumps and steps is because we now have the opportunity to not just go to the right on our number line, we can now go to the left into the negatives, and direction matters when it comes to multiplication and division. Let's say that you are starting at 0, but now you have to get to negative 15. Once again, you're only allowed to take equally sized jumps. What do? Well, we can just go the other direction. Take 15 jumps, each covering negative 1 steps. We have to say negative 1 because the direction matters. We're now going to the left into the negatives. We could also take one huge jump that covers negative 15. Again, we have to say negative 15 because we are moving to the left. The direction matters. What other jump patterns can we take? This is similar to our first problem when we were going to positive 15, except for now we're going to negative 15. We could take 5 equally sized jumps, each of those jumps representing negative 3. We have to say negative 3 because we're going to the left. Or we could take 3 jumps, each covering the distance negative 5. 0 to negative 5, negative 5 to negative 10, negative 10 to negative 15. Mentioning the negative with those numbers is important because it indicates the direction we're moving. So what do these drawings and jumps turn into in terms of multiplication problems? In red, we took 15 steps, 15 jumps, mind you, and each of those covered -1 steps. In green, we took 1 jump, and that covered a distance of -15 because we moved to the left. In blue, we took 5 jumps, each of them covering -3. And in purple, we took 3 jumps, each covering a distance of -5. Notice that all 4 of these problems will give us the same answer, -15, because these negative signs indicate that we are moving to the left in the negative direction. How does this turn into division? All right, we need to get to -20 from 0. We're only allowed 4 equally sized jumps to get there. How big is each jump? Remember that direction matters, so we have to include the word negative when we talk about how long each jump is. Each of our jumps is going to cover a distance of -5. 0 to -5, -5 to -10, -10 to -15, and -15 to -20. What other jump patterns can we use? What if we were only allowed 2 equally sized jumps? That would take us from 0 to -10 and from -10 to -20. So each jump is worth -10 steps. If we're only allowed 1 jump, it's 1 jump from 0 to -20, covering a distance of -20 steps. How do these turn into division problems? The first one, in red, our destination was -20. We were allowed 4 jumps. That means each jump covered a distance of -5. We have to have the negative in there because it indicates the direction we are moving. In green, our destination was -20. We were allowed 2 jumps to get there. Each jump covered a distance of -10. The negative is necessary because it indicates that we moved to the left. And finally, in blue, if we need to get from negative to -20, we only are allowed 1 jump. That jump has to cover the entire distance of -20. Again, the negative is necessary to indicate direction. How about these problems? We're not going to worry about drawing anymore. We're just going to do this straight out of the book. 5 times -6. The trick with multiplying negatives is to just do the math the way you normally would. 5 times 6 is, and always has been, 30. And since there is a negative sign here, we throw a negative sign into the answer. 8 times 3 is always 24. But because there's a negative sign here, we put a negative sign in the answer. 45 divided by 9. 45 divided by 9 is and always has been 5. Because there's a negative sign, we put a negative sign in the answer. And 12 divided by 4 is and always has been 3. Because there's a negative sign, we put a negative sign in the answer. Last thing to mention. Notice that every single one of these problems has 1 positive number and 1 negative number. +5, -6, +8, -3, +9, -45, +4, -12. There is a special rule if both of the numbers are negative, but we'll get to that next week.